That was a total accident. That song finished exactly at that point. Yeah, we get lucky sometimes, don't we? Hi, hi. Yeah, what's system crafters? Tintin Tong. I'm not really sure. I'm gonna look it up. Shall we look it up quickly? Let's look it up. Look it up. A new awesome Emacs stream. Oh wow, there we go. I mean, you can watch me struggle, or you can learn something. Ooh. Which one to pick? System crafters. So they've got a YouTube. They got a Twitch, I guess. Is it on Twitch? No, maybe it's on YouTube. Would be my guess. I don't know. It's in an hour. Oh, right, yeah. Oh, okay, cool. Live. There he is. He's in Emacs. Oh, look at that. Oh, see, this is why it's convenient, because he has a schedule. Look at that. It even says it. Hold on, no. Whoa, whoa, whoa. It's gone loud. It's gone loud. Calm down. I need to find my thing. This was not expected. Yeah, see? But it says Friday. So is he going against what he normally says? Because as far as I know, today's not Friday. But it does say live here. I don't know. Emacs, how do I debug your code with that? Let's stop, you know, like... oh, hey! Chiroptical. How's it going? I'm just advertising another stream. That's the way you do it, isn't it? You like hope people come to yours and you just go, look at this one. It's far better. So anyway, we're going through this great book, and I'm looking forward to doing a couple of hours of struggling. Hey, Leo or Leon? I couldn't remember. Was it Leo or Leon? Can confirm the great book. Yes, it is good. Oh, hold on. You gave us a link to yours though, didn't you? Is it in my history? It should be on. I thought I saved it. It's in a different. Oh, it's in my other. I've got it open down here. I'm not going to open that because who knows what's on there. On GitHub. Oh, so you've actually. Oh, but didn't you? It is Leo. Sorry, Leo. Leo. I've gone. This will find that one. We've got that one. Oh, and the YouTube links are in there too. Here we go. There they are. Playlist. I knew it was somewhere. There it is. Whoop whoop. I know. Been on it. It's been there. Done that. I'm here. Well, you know, I can always be second best. That's what we aim for. So there's the book. And, oh, there. Well, you've seen the link. Or if you're watching on YouTube, yeah, it's there. It's only like 24 hours of content. You can do like, you know, someone, yeah. That's a lot though, really, isn't it? How amazing is that? You just like boshed out 24 hours of content just like that. That's pretty impressive. Well, I guess it adds up, but yeah, it is. It's pretty cool. So we're now working with types. Hopefully, I've got a good feeling about this one. I think I've done it before, but yeah. Today I've got a good feeling. Don't you worry. I'm not boshing it all out. I don't think I could do if I was to literally stay up 24 hours doing that book. Do you reckon it's doable? I don't know. I don't think I'd be able to do it. I've got a feeling that once I get to sort of like chapter 6 or 7, there might be a pause on this this series. I think I'm gonna have to do some digging, some self what do you call it? Something, or rather, when I forget words, I'll just make up words. It's the best way. Don't do it to yourself. Oh, what's going on? COVID hobbies. Don't do that to yourself. Your brain may melt through your nose. Will it be like? Here we go. I'll be definitely doing lots of this. There we go. That works. There we go. Yep. There we go. All right. Go away now. I need to get. I think like pro streamers have like little pads, don't they? Like, pow, 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 pow. And then they can go bam, go to this scene, bam, do that. But I'm not a pro streamer, so this is what you get. You get me looking to the side, losing a bit of volume because obviously then the mic's not facing my mouth, and I have to, and then I headbutt the mic also just to add a bit of, you know, tension, and I'll do that, and then I switch it off. At least it fades in and out. That's exciting. Yeah, right. So yeah, hopefully my COVID hobbies, is it COVID? I don't know. Maybe it is. I think it's more searching for work hobbies is what it's turned into. Because I've been currently looking for a new role because I got made redundant. Boo. Sort of 2-3 months ago. Yeah, so I'm just searching for something else. And I don't really want to do something crap. So yeah, I'm being quite specific, I guess. So now I'm doing a needle, inside a haystack. That's what I'm trying to look for. So I've turned my attention to streaming. So rather than just sitting there and being bored and maybe just learning stuff for myself, I thought, why not teach? Because then you're doing two things. Fortunately, you don't get paid, but you know, it's good for the community. That's the way you got to see it. Right, let me know. I think that font, I've been using the font size over here like this, so I think it's okay, but oh no, that's probably a little bit too big. Well, for me it is. Yeah, I think because I've put up the stream quality as well. We should be on 1080, so crisp. Didn't know if I could handle it. Well, I know the internet can handle it, but I didn't know if my laptop would go mental. It's still whooshing like hell, and it's on 9%. Or whatever. Deal with it. CPU, that is 9%. Right, so we're chapter 4, working with types. We've done obviously 1, 2, 3. If you want to see the past ones, I need to be better at plugin. So there's that one, this one, and then I need to go to my channel, your channel, that one, and then playlists, and then we've got a bunch of these. Thinking with Types, book by, I should have put a comma there, shouldn't I? Yeah, don't worry about it. Grammatically correct. Who wants that? Here we go. And that one. So if you want to see the past chapters, we've been lucky. We've done 1 chapter per stream. But the way I'm going now, because I won't shut up and get on with it, it looks like we might not get to do it. So get on with it, Vince. Stop plugging. I mean, it's not a very big plug. So, typescoping. Haskell uses a generalization of the Hindley-Milner type system. Good old Hindley. One of Hindley-Milner's greatest contribution is its ability to infer the types of programs without needing any explicit annotations. The result is that term-level Haskell programmers rarely need to pay much attention to types. Okay. It's often enough to just annotate the top-level declarations, and even then, this is done more for our benefit than the compilers. This state of affairs is ambiguous. Well, we've clearly worked out by now that I say random stuff, and I struggle sometimes with word. I can see it ambiguous. Carry on. And the message is, I know exactly what it means, ambiguity, whatever. It sends is loud and clear. Types are something we need not to think about. Yeah, unfortunately, such an attitude on the language part is not particularly helpful. Yeah, I was going to say, I don't think that at all. But I didn't want to say it straight away. You know, let the writer, someone more experienced, let Sandy make that statement, not me. Such an attitude in language part is not particularly helpful for the type level programmer. It often goes wrong. Consider the following function which does not compile because of a type annotation. Oh yeah, this is quite interesting. Hold on, Mike. I don't know if it's too loud for you, but it is a bit too for me. The music that is. So, except when I copy and paste this, it's going to be like that. Yeah, to be expected. That's fine though. We'll just quickly do some of this. So this is cool. I remember this now. What are we doing? We're doing A to B to A. Okay, yes. It should not be happy, but I guess I need to restart the Haskell language server. Something like that. Yeah, there we go. It's complaining. That's fine. That's what we expect. So, except, oh, okay, well, I'm missing the actual apply, which is FA. Okay, but then it's still, yeah, so it's not. Because what it's saying here is, it's saying B, well, you'd have a notion of, or thinking that maybe when you refer to B here in that type, it's actually referring to that B. But the compiler is basically a little bit cleverer than that, and it sort of goes, oh, well, I'm essentially explaining what's written, but it actually is under the hood. It doesn't at all, you know, if you don't have any extensions, it doesn't refer, it just thinks that's a new type. So not the keyword new type, but another type of C. So the problem with broken is that despite all appearances, the type in B in apply is not the same B in broken. Yeah, so that one, hold on, let me zoom in a little bit. I just had to think about that. Maybe I'm not big enough. There we go. Or maybe another one. I'm going to go another one. Let's do it. Yes. So this B has got nothing to do with that B. Want to become famous? Buy followers, primes, and viewers? Hell yeah. Ban. Oh, ban them. I should get a bot to do that. But I'm not doing that. Yeah, did you get them? That's some big followers I got with loads of people build bots like that. Maybe that's why it seems like I've got more watchers today. It's just the bots hanging in there waiting to comment with their spam. Love them. Oh, I put the videos up as well on YouTube, and instantly, well, within like the hour, I got loads of comments. I was like, oh, that's unusual. Looked, and it was all like for, you know, my mum next door and stuff like that. I was like, damn. No comments. It was just spam. Sorry, I'm just drinking. Okay, so Haskell thinks it knows better. Of course it does. Than us here, and introduces a new type variable for apply. The result of this is effectively as though we had instead written the following. Yeah, it's a broken, so you know it's just saying that could just be a C because that's all it thinks. So that's fine. So Hindley Milner seems to take the view that types should be neither seen nor heard, like children, isn't it? That's what they say in the old days. And an egregious consequence of this is that type variables have no notion of scope. Oh, okay, yeah. So that's basically it, isn't it? It's just saying, I don't know what scope. Well, I'm just on my own scope over here. Thank you. Well, within types, but obviously you've got this available to you in scope, but not with the types. Where did it go? Yes, this is why the example fails to compile. In essence, we've tried to reference an undefined variable, and Haskell has helpfully created a new one for us. Cheers! The Haskell report provides us with no means of referencing type variables outside of the context in which they're declared. There are several language extensions which can assuage this pain, can help with this pain. I love it. See, this is the thing. That's the thing that sometimes, is it just like in tech or just, I don't know. Yeah, carry on, Vince. Don't. This is a good book. Don't complain about little things like that. Yeah, maybe it's just me that struggles. I just think, you could have just says it can help or it can alleviate this pain. Sewage, alleviate, probably the same, isn't it? Anyway, the most important one being scoped variable types. Hold on, does it allow us? This, I think, should ideally... no, it can't. What do you mean? I thought it was going to give it to us as an option, but I guess it won't. Okay, we'd have to put it in manually, which I assume... Should we just do it? Yeah, let's just do it. So I want to... I think... is it going to be lowercase? I can't remember. Scoped. Type. Scoped type. Variables. And then that's just... Okay, so it should be... You'd think... I mean, it'd complain if that's wrong. So let's have a look. Are you going to complain? Don't complain. Please, please, please. Not complain. Help us. That's what I mean. Okay, well, I've done something wrong. I think, oh, isn't it all lowercase? I'm sure. Have we not? No. I was hoping that it'd be somewhere else. Doesn't it show you later on? Scope type error. Maybe I spelt it wrong. Maybe it's all lowercase. That could be another. Well, no, have that. Maybe, whoops. Language. Spelt that right. Okay. Oh, no. So it's happy with it. Look. But it's still... Because look, if I misspell it, then it says that doesn't exist. But if I put a capital S, then it's happy. But then it's still not happy here. Okay, so I guess it needs something else. I can't remember. Let's keep going. Oh, okay. For example, with broken, it's still broken. Okay, keep... Hey, need to read on. Remember, Vince. Don't just, you know, read literally the next few words it told me. But the following works. Working. Oh, so if you do a for all, yeah. So if we create a type of for all a b dot, and then we've got a, whoops, to b, and a, where am I now? A to b, and then we'd have fa equals, what have we got? Apply, where, and then at that point, we've got, is that because of the for all? I guess that's why. Oops. F A. Cool. So hold on. One of them should work and one of them should fail. So I'm just going to reload. Yeah, it's weird, isn't it? I don't know why the Haskell language server just sometimes it works, sometimes it doesn't. It's a bit of a bummer. Cool. Okay, so we got what we expected. So from here, it looks like because we've for all'd them. So when we write, I mean, I'm sure, well, in case you didn't know, but for all constraints that all the A's have got to be of exactly the same type, and then all the B's have got to be of exactly the same type. Yeah. But what does it say here? So the for all AB quantifier introduces a type scope. Okay, and exposes the type variables A and B to the remainder of the function's definition. This allows us to reuse B, when adding a type signature to apply. Rather than introducing a new type variable, as it did before, scope type variables lets us talk about types, but we are still left without a good way of instantiating types. If we wanted to specialize fmap to maybe, okay, if, I needed to know where I am. Yes, for example, the only solution sanctioned by Haskell report is to add an inline type signature. Okay, so if we want to implement a function that provides a string corresponding to a type's name, oh yeah, this bit's cool. It's unclear how we could. It's almost yesterday in what were we doing? Is it something? I can't remember. What was the example? We were converting the number, weren't we? It's coerce. It's not unsafe coerce. That's pure script. Where we were converting the chain of types, so we were using the sum type, and then we were converting the sum type was of value 1, 2, 3, 4, 5, and then we were converting them, but it returns 0, and we were doing +1. But this is like a cool way of doing this. Well, it's a totally different way of doing this. What am I on about? Keep going. Shh. Calling such functions would be difficult. Hold on. Yes, it's unclear how we would do such things. By default, we have no way to explicitly pass type information, and so even calling such a function would be difficult. Some older libraries often use a proxy parameter in order to help with these problems. Its definition is data proxy. Yeah, this one was like, I come across proxy a lot, but for some reason it doesn't quite fully sink in. Actually, should we put it, so we're doing here, what I'll do is I'll comment this out so then we don't keep getting errors. And then I'll pop this here. Because this is about so you, whoops, and that just equals proxy, doesn't it? This is like, it's like phantom. I was going to call it a ghost, but remember it's a phantom. So it's a phantom type, isn't it? But yeah, for some reason it throws me a little bit. I don't know why, even though I've used them, because you tend to use these sorts of things when, well, especially in PureScript when doing JSON, when you're sort of changing JSON and stuff like that. But anyway, all to help with these problems, its definition is this. So we've done that. In terms of value level, information content, proxy is exactly equivalent to the unit type. Okay. Oh, is that someone outside? Sounds like I've got a classical singer outside. But it wasn't. It's probably some Scally. Scally's like yeah, if you're English, you know what Scally is. If you're not, it's like a, don't know. What's a Scally? How can we best describe a Scally? Scallywag. There's a Scally. No. There we go. That's the sort of Scallies we get in our country. Like that. Hanging tough, you know. Rude boys, I guess. Rude boys. Look at that. Get the little shaving right there. Anyway, back to Haskell. I always sidetrack, don't I? Can't help it. So, whose only purpose is to allow users to keep track of a type and pass it around like a value. Yep. Okay, so it's literally just a wrapper for your type. I guess is the best. Probably not a very good way to say it, but I'd say, you know, keep track of type. For example, the module data typable provides a mechanism for getting information about types at runtime. Oh, okay, yep. This is a function typerep whose type is, okay, so let's first and foremost we'll yes, we'll get rid of that. Oh, hold on. Oh, we'll do, oh, it's just gone mental. Here we go. We'll do some of, there we go, and then we'll import it, because shall we? Yeah, let's do it. So because I think it uses it later. So what, data typerep, isn't it? Typable, sorry, theta typeable. No, come on, it's down there. There it is. Cool, you're happy. And I guess then we'll have typerep in scope, won't we? Yeah, we will. Okay, so data typeable and the function typerep whose type is typeable A, proxy A. Oh. Hey, Pat Faraji. Hey, sorry to disturb you. I see you are using Doom Emacs with Haskell with autocomplete and everything, absolutely everything. Do you know if there's a good tutorial on how to set them together? I am new to Haskell and Doom Emacs and it's kind of complicated. Yeah, it is kind of complicated. Where was it? Well, there was some. Oh, hold on, I can bring it up. There's not a specific to it. It can be a little bit complicated. We kind of went nuts. Who was trying it? I'm going to see, because I remember it's someone from the stream. Again, names, me, equals, crap. Slack? Let's get in Slack. I'm just going to quickly sideline, because there was, and what I'll do, I think it was a thread that I was a part of. It certainly was. Here we go. Oh, it was Tinting Thong. I knew it was someone. Yes. Here we go. So hold on, how can we oh my goodness, how can I give you this? Oh, I know what I'll do. Here we go. I don't know. I mean, this is technically you're meant to be able to just there's instructions on so there's instructions here. Where is it? With Doom Emacs. Somewhere it says Doom. There we go. Yeah, so literally you're meant to just be able to do that. You bring in LSP and then Haskell LSP, because the Haskell is essentially a standalone server that just runs. Sorry, the Haskell LSP or Haskell language server just is a standalone server that runs using LSP. But the problem might be that you'd need different versions of Haskell. So what I'll do is I'll give you this quickly. Where's my music gone? It's because it's finished. There we go, we started again. So that one's a link to this, and then what I'll do, yeah, is maybe pass all this. Did you get it going? Ting ting tong. Tin tin thong. Sorry, I'll get it right. Where should I put it? Should I put it in a gist? Gist. I've got my own somewhere. There we go. We'll go in there. I'll pop it in here. Yeah, at the top of this one, because this already exists. Or should I make? I'll make it. Yeah, I'll pop it in here. I mean, there we go. I'll put it in a comment. Okay, there you go. I think that's got everything. I'm not going to do, it's going to look like that, so you'll have to deal with it, unfortunately. But I can give you a link to this. And that's probably as far as I know. The way I did it is the only reason I'm passing you on to this is because I use Nix I'm on Mac OS, but I use Nix as well. And then what happens is, because Nix, in the way that it works, so I'll demonstrate. So if I go in here, I can go which GHC, for example. There we go. So I've got version 883. If I come back, I'm like in a lower module now. Sorry, in a lower folder directory, and GHC doesn't exist there. And what that means is I can. I've got it set up so obviously Nix works on per folder basis, and with each version of GHC, I've got a version of the Haskell language server that runs with it. And that's the main problem, because each version of GHC needs its own version of Haskell language server. And then if you read the link that I've just sent you, it kind of it explains that a little bit. And there's kind of ways to make that happen. But I think in the newer versions, it's meant to be what was said actually. Let me try and remember. I'll have to press my own link. I've just got rid of it in the comment. I think the idea, yeah, it uses the Haskell language server wrapper, and that's meant to help. But yeah, if you're stuck, I'd definitely go onto the Slack of the FP Slack. I need to set up all these links, don't I? What was it? FP Slack invite. There we go. Get on here. Go ask some questions, because everyone's super friendly. Or if you're already on there, then yeah, there goes that. Cool. That's the best, unfortunately, because it's certainly, I'll be honest, it's not a quick. It's not. I don't know. It depends. We'll see if. Yeah, no worries. We'll see if Tin Ting Thong sort of asks, or if he chats again, then we'll ask him. Yeah, because that'd be the best bet. Because he was trying to do exactly what you're doing, ultimately. Cool. So let's do something else actually whilst we're here. I'm going to open up the REPL. I'm going to go check some things. Yep. These are just warnings telling me that I've got loads of imports that I'm not using, which is fine. I don't mind that. But we're going to load. What file? We're going to load this file? Yeah, go on in. Chat. You should be finding it. Come on. Wait, why not? Ah. What do you mean? What happened? Well, hello. That was weird, wasn't it? Load. Oh, okay. Oh, I was in the wrong buffer. Yes, that's fine. Okay, so now, technically, we should have... what was it? Type rep, isn't it? Type rep. There we go. So we can see the type. There we go. Okay. I'm just double checking we're aligned with what's going on here. So it provides us about types at runtime. This is a function type rep whose type is typeable A, proxy A, and type rep. Again, proxy's only purpose is to let type rep know which type representations we're looking for. As such, type rep has to be called as like this. Okay. So what happens if we call that? There we go. We get back bool. Makes sense. We use it later. I think that's like a little hey, check this out. And then later we'll do some magic with it. So I think that's what happens. Oh, there we go. Oh, Sue PP's going to reply. Are you interested in trying some other setup other than Doom Emacs? VS Code. Yeah, VS Code is just plug and go. That'll do it. Don't struggle yourself, and definitely don't install Nix to try and get this working, because be prepared to spend about a week, which is what I did. And now somehow, by some miracle, I have it working. But all I have to do to get things going, essentially, is I have to do the command doom sync like that, and whichever folder I'm in, and then I have to open Emacs from within that folder, because I use a standalone version as well. Some people also use Doom from within the terminal. With, but I don't. I just use it. I guess it's from my old front end days. That's what I do. Right. Clearly, Haskell's type application. Clearly, Haskell's inability to direct specific types has ugly user-facing ramifications. The extension X-type application patches this glaring issue in the language. So, should we set it? Hold on. We'll put it up here as well. What is it called? Type applications. Okay. Type. I wish it normally it does have it, but I don't know why. That's not finding it for us. I mean, it's basically saying that that's right, because if I was to do it like this, then it'd fail, but like this, it's fine. I thought it'd have predictive on that, but it doesn't. Never mind. Okay, so what we'll do is we'll reload that, and then hopefully, does that mean it puts that into scope? I don't know. Let's find out. Let's do the type of. Let's do that. Oh well, first we can do this. Yes, this is really cool. This is cool. Yes, okay. So I don't know if the next one is going to work. So there we're just doing a type of emap. Yeah, okay. I need to import it. That's fine. I need to set it in the REPL. I thought it'd maybe sort of take it from the page, but that's fine. And then that one. Yeah, how cool is this? So it's basically saying fmap at maybe. Okay, so it's saying that the value of the f is going to be maybe. So if we look at there, f. So because the constraint of functor is f, and then we're saying, well, that constraint of f, and we know that maybe is a functor. Well, we're going to say it's at maybe, and then you see how it converts it. Because when we look at Haskell normally, it just says blah, 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 and here we're just going blah, blah, blah. Cool. It's now a maybe and a maybe. That's handy, isn't it? Oh, I was trying to do that the other day, but I forgot. Okay, let's try and remember. We need to add. Where was it? Oh, I thought it was a set. Okay, well, anyway, we need to do a type applications. We need to set that. Okay, so X-type application. X-type applications. Cool, because that's really handy, because you can do at whatever. That allows you. So while fmap lifts a function over any functor, fmap at maybe lifts a function over maybe. We've applied the type maybe to the polymorphic function fmap in the same way we can apply value arguments to functions. So that's what we were saying before, that ultimately you can think of types as other functions in a way, can't you? So if we're able to do this little trickery, so we're checking out the type of fmap, and then we're assigning, well, we're telling the compiler what the f is, and then we're saying, well, it's a maybe, and then it's able to put them in the correct space slots, I guess. And that point it's saying, well, it's maybe blah, 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 maybe A, maybe B, A to B. Sweet. So that's good. There are two rules to keep in mind when thinking about type applications. The first is that types are applied in the same order they appear in the type signature, including the context for all quantifiers. This means that applying type int to AB, A results in int B int. Yeah, okay. So it's basically saying it's gonna, once you add, let's have a look then, let's try it. Let me test this theory because I think I know what it's saying. So fmap, smap, oh my god, Couldn't spell it any worse. I've tried every single version, right? Fmap, and we'll go at, what was the first one? Maybe, wasn't it? So we'll do at maybe, and then we'll do at int. Let's see what happens there. Yeah, exactly. Right. So if we look at the very first fmap here, so it's going to take whatever comes first. So we know that the next value that we've got available here is A, and then it slots in all the A's because that's the second value we pass to fmap. So I guess in a way you can kind of look along the type definition, and then we can see A and then it'd be B. So if we then do the type of, I don't know, let's say that the B is at string, for example. No, we'll do at char. There we go. Now we've got it. But I assume this would then, oh, what is going on here? Then we're just converting everything to ints. Oh, hold on. That's right. No. I wanted to do, yeah, I wanted to check if it breaks, if it has more. Yes, I'm like passing too many here, aren't I? Clearly. Okay, so it's, am I? No, I'm not. You've done it again. Okay, at char and at int. Now I've got too many. Go away. Go away. Oh. Yeah, there we go. Okay, that makes sense. Whew. That's good. I thought it was, I thought, hold on, how's that working? But it's not. Yeah, so that's fine. It's, well, I mean, it even sort of says it, that it doesn't quite say it, we've passed it too many, but that's what's happening. So that's cool, and I think this is what's explained over here. For all, this means that int to A, B results. Oh, hello Haskell. Today's stream is buffering on my cellular connection, almost unwatchable. I don't know. I've only got, literally, it's doing really good here. I've got drop 1. So I don't know what that might be. Ready? And I can even, I'm pretty sure I can watch myself. Yeah, I think your cellular connection is eating you alive. And watch this. We'll just, what is this? Twitch. What am I on again? Yeah, if I go on it, I'll be, oh, it's going to be a horrible experience. There we go. Okay, we've seen that. So yeah, so it didn't kill it on mine. I don't know. Oh, it's 1080. It's 1080p only. Maybe, yeah. Maybe bring down. Hey, Gil Christian. Maybe bring down your. I think you can do it, can't you? cmdv-tv. I think you can bring it down, can't you? Is it an option here? I don't know if you're on your mobile though. I'm not going to speak because then I have to listen to it. There. Okay. It's showing fine on mine. Sorry, I don't know what it is. Yeah, something. Can't help you. Not technical support. I'm only kidding. What a sod. How horrible am I? Okay, so including concept. Blah, blah, blah. So int into A, B, A would give it int, B, int, but applying for all B, A, B, A, in fact, yes. Yeah, so if you look, what it's doing, this example, it shows a for all. So for here we had fmap, and it went along, where was it? Here it is. And it went along, so it grabbed the F, then the A, then the B. But if you've got it in a context where it's using for all B, A, and then that, well, the first value you pass it, which is an int here, that would be the B. So then it'd leave those A's alone and then change that to an int, which is what it's saying. So recall that type class methods have their context at the beginning of their type signatures. Fmap, for example, has the type functor f, blah, 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 blah. This is why we were able to fill in functor parameters of fmap, because it comes first. Yep. Second rule. Okay, here it comes. The second rule of type applications is that you can avoid applying a type with an underscore. Hello. This means we can also specialize type variables which are not the first in line. Looking again at GHCI, we can type apply fmaps A's and B parameters while leaving the F polymorphic. Yes. Oh, so basically, oh, that's the only variable to next tier streamers. What is? Oh, what to lower the... Besides, so I'd have... Oh, is that what's happening? My quality's too high for everyone to watch. Well, I mean, yeah, that sucks, doesn't it? Is that what you're saying? I think you're saying. Next tier with streaming partner. How do you become a partner? I mean, I don't even know how all this works. Let me know. Send it. Post it to me. Okay. So I guess I'd have to have a lot more viewers would be the idea to be a partner, isn't it? Which ain't happening, is it? Let's be honest. Right. Let's carry on. The second rule of type application is yep. And then we can see if we do here, yeah. So if we just put at on the first value, it's going to leave the F alone. Actually, it's called it W right there. Yeah, so it's going to leave W alone, and then it's going to replace the A and the B with an A and a B. Yeah, well, sorry, int and bool. So it makes sense. So because types are applied in order, they're defined in the presence of X-type applications. Types become part of a public signature. Changing the order of type variables can break downstream code, so be careful when performing refactors of this nature. Yep. Okay, we'll be careful. Pay attention to type order whenever you write a function that might be applied. As a guiding principle, the hardest type to infer must come first. Okay. Oh, 75 viewers average. Well, yeah, that's not going to happen for some time. Look, I mean, I had like a peek the other day at people that do, other developers that do streaming, and I mean, I don't know. Look, they don't have any of things like this. I didn't see any of that. Hey, no, I don't think we did. Didn't see. Okay, I'm gonna hold on. We didn't see. Yeah. So basically, I think it's just about the language, and because I've chosen to stream in potentially not such a popular language yet, peaking probably at 15 would probably be like a good going, I reckon. If you peak, I mean, I don't know what Vlad does. He's like probably the most popular FP streamer, and I've so far really only been doing primarily Haskell. I've not really done any pure script yet, but Vlad's like he does like maths as well, so he's out there. But I don't know what he's doing like on his dailies, what like watches. I don't know. I don't know how it all. I just try and ignore it, because if you get too much into it, then you end up chasing. No, TS coding. Yeah, he's another dude, isn't he? A dude. What a descriptive. No, TS coding someone. Vlad is CV lad FP. Here we go. Look, let's plug Vlad. CV lad FP. There it is. It's not on. So what has he got? He's got like, look at that. Wow. Shut your face. Yeah, there we go. He has 3.5k followers. I've got 50 something, maybe 60. Can't remember. So yeah, I don't know. Yeah, I'm definitely. I remember seeing that TS coding ages ago, and I guess he's been going for a while. So I don't know. Yeah, I'm definitely 100% not doing this to chase the numbers. The most I've made so far, I think, was Alex Ch4 gave me 100 bits or something, whatever they are, bits. Yeah, and I don't even know what you can do with it. So, yeah. You know, this is Vince. Keep looking for that job, because Twitch ain't gonna be it for you. That's what I'm aiming for. Right. So where do we go? Yeah, blah 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 blah. They go hand in hand. Yeah. So it's just saying scope type variables and type applications go hand in hand. like little friends. So returning again to an example of data typables typerep function, we can use it to implement a function that will give us a name of a type, and we can do it so without requiring the proxy parameter. Yeah, this is where it's cool. This is the bit I was just like, wow. I remember seeing this and going, well, the heck, this is impressive. Okay, so if we do for all A, not an S, an A, so we should have that in, yes, we've got that in scope. And then we'll do a constraint of typable, and then we'll return a string. That's the idea. Okay, that makes sense. And then if we do type name again, and then we do show, we compose it with the function typerep. Is it going to find it? Yes, of course it is. Ah, yeah. Oh, this is so cool. So proxy at A, it should be. Yes. Okay. Yes. There's no errors, hopefully. I'm going to refresh it because I saw a little one. Ah, this is what I want to know. I don't think anyone will know, but it's quizzed me a little. Yeah, so that's you get a little one here. What's this got to? Sometimes it shows up when there's, and then I click it. Oh, hello. Okay, so it does show me stuff. Didn't know that. It's definitely not happy up here. I've probably typed it up. Let's have a look. Have I typed it wrong? A for all A. No, I haven't. But it's still not happy. It's got an error now. Have I used the wrong typable? Probably. Or do I need to allow? Should we just do that? Yeah, it's happy now. I don't know if that's right. And I don't know what's going on here. So what I'll do with this one is close that. And go back to here. There we go. We got it. We're back. Okay, so let's have a look at that. Type name. So for all A, typable. So it's constraint to the A saying is going to be a typable of A. And we're going to return a string. And then we can use typerep. So if we look at the type of typerep takes a proxy. So for all K, a proxy of K to type. A is of type K. Well, hello. Okay. Okay. And then dot. Typable A is a constraint, and then it's a proxy A, and it will return you a type representation. Whew. I think it goes into what's going on. Well, first and foremost, potentially not here, but it does about here. So from memory. So there are two interesting things to note in type name. At 2, proxy at A is written as a shorthand for. Oh, okay. Proxy A. Oh, okay. So you can. So instead of doing. Hello. Why? Go away. So instead of doing that, but that's what it's saying. But it's not happy there for show. Could not match type proxy. So I guess. Oh no, it is. It should be the end wrapped. Oh. No, that can't have fixed it, surely. Or maybe it did. Maybe it assigned the whole thing to... Yeah, it would have. Okay, cool. That makes sense. So we're just saying that... Yeah, cool. Okay, that makes sense. So we can, instead of doing that, we can make it shorter. Shorter? Cool. Thanks for coming, 2PP. See ya soon. Where was I? Yes, okay, so that's a shortcut of that. It works. So that's part 2. This is because proxy data constructor has a type proxy T. That's because the proxy data constructor. Oh, okay. So if we like hover over this, it's not. Oh, okay. So it doesn't quite show us that, does it? Because proxy data constructor has a type proxy T. It says proxy A, which is the same. Okay, the type variable T here is the first one in its type signature, so we're capable of type applying it. Okay, type applications aren't reserved for functions; they can be used anywhere types are present. Oh, okay. Okay. So at 1, it's over here. So the first line, we see that the type A doesn't actually appear to the right of the fat arrow context. So yeah, it's just available here. It's never used. So I was like, well, why? Because Hindley-Milner's type inference only works to the right of the context arrow. It means that type parameters A in type name can never be correctly inferred. Okay, Haskell refers to such a type as being ambiguous. Okay, so by default, Haskell will refuse to compile any program with ambiguous types. Yes, I've seen that error. It just goes, yeah, ambiguous type, do one. We can bypass this behavior by enabling... Oh, isn't that what we just did? Allow... Yeah, that's why it was complaining. So there was that error, and then I just followed the Haskell language server and went, yeah, add that. And then later it goes, add this. That might have been a little bit frustrating. Now, if you're doing the book and you're like, why is that not working? Why is that not working? And then if you're like me and you try and fix it before you read on, you'd have been stuck there for a while. But I just trusted Haskell language server and went, yeah, you know your stuff. I'm going to follow what you told me to do. And I just did. Anyway, to aptly named allow ambiguous types. Yep. Extension anywhere where we'd like to define one. Actually, using code that has ambiguous types will require X type applications. Yeah, so we've got that as well. The two extensions are thus either side of the same coin. Allow ambiguous types allows us to define ambiguously typed functions, and type applications enables us to call them. So that allows us to be... So ambiguous allows us to do that, and type applications allows us to call it from here. That makes sense. And that's what it's saying, isn't it? Yeah. Right. We can see this for ourselves by enabling. We can compile type name and play with it. Okay. Let's do it. We'll do that. And then we'll reload here. Reload. And then we'll do that. Okay. So, type name. This is cool. This is cool. Type name. Yeah. So we can pass it at bool. Look at that. What sort of voodoo magic is this? It's pretty cool though, isn't it? So, type name. What was the other one? At string. So it literally is returns to string. So because we're able to... Yeah, because we're... So it's what was going on before, wasn't it? You know, when we were passing to fmap, we were saying at int to fmap, and then that was passing it along. And sorry, we were doing at maybe to fmap, and it's passing along into the type definitions, and then it make it more concrete. Well, here is essentially the same, except we're making this ambiguous, so it's just sitting around. We can then fill it with a value. So for us, it's string, and then from there we grab it out and create it, put a proxy around it, use type rep that then converts it to a type rep, and I guess type rep has a show instance for it, and then you can just show it. That's, you know, I don't know. I'm pretty impressed by that. If you ever want to have your, for some mad reason, have your types come out as strings, there you go. I guess it'd be good for like a visual, because sometimes people set up types, you know, so they have like their whole type system can be a visual representation of what their program's doing. I did see that in my last place I was working at. It was in Pure Erl, which is like an Erlang. I keep saying don't I? Excuse me. It's a Pure script, a different backend for Pure script that compiles down to Erlang, and they had a similar thing where they'd be able to demonstrate the application. So you get like a tree, an application tree via the types. I think that's what it was. I didn't really see it. I saw it a couple of times. I was like, well, what's this? And then they kind of went, oh, is there a... So I didn't really get a good look at it. It's like, oh yeah, we did this and we don't use it anymore. I was like, oh, okay, cool. That's a shame. So, though this is a silly example, ambiguous types are very useful when doing type level programming. Often we'll want to get our hands on a term level representation of types. Think about drawing a picture of a type, or about a program that will dump a schema of a type. Yeah, exactly. There we go. Drawing a picture. That's kind of what I was saying. Such a function is almost always going to be ambiguously typed, as we'll see soon. Okay. So, however, ambiguous types aren't always this obvious to spot. To compare, let's look at a surprising example. Consider the following type family. I'm not going to consider it. I'm going to type it out. Let's go up some. Let's go up. So type family, and it's going to be always. Servant. Yeah, it does use it a lot. So it's sorry, Haskell's put servant uses it a lot. Yeah, of course it will do. Yeah. Oh, I was trying to remember where I've seen it. Yeah, in YESOD, you use it, and also you use it when you do your stuff for your database. You do it there as well. So yeah, it is used a lot. That's cool. But I guess you don't really. I don't know. The thing is with Haskell, I've always just been able to use it. So I can. What I'm really good at is looking. Say someone's done something already. I can go through it and I'll be able to add to it and amend it and whatever. But where I've always struggled is doing things from scratch, essentially. So that's why I'm doing more of this. I want to, I don't want to just, I want to be able to, well, I guess ultimately be able to do like what people that make libraries do, get to a high level. But I don't want to forget that you can do Haskell without doing all this, well, it's not crazy stuff, but, getting this far ahead, basically. Is it far ahead? Yeah. Remembering, you don't need to go to do too much clever stuff to be productive. So, given in this definition, are all the following type signatures non-ambiguous? Take a second to think through each example. Non-ambiguous. Okay, so we know things are ambiguous, but that always returns unit. This is ambiguous, and then a non-ambiguous would be where the A is used. So this is non-ambiguous, I'd assume, because the A is being used. Yeah, seems right to me. B, always unit A to B. Oh, I'm failing to see which one's ambiguous then. Show A. Is it this one? Hold on. Always, oh no. Always unit A. No. But that's always going to be unit. So maybe the first one? Oh, I don't know this one. I don't know. Oh, so it's the third example. Okay, so we've got an answer. Okay, so my intuition was right. So take a second. I took potentially less than a second to think about it. So let's look. Always unit A, and that returns an A. So we've got nothing ambiguous there, because we kind of we're able to know what the A is and return it. Okay, so that's fine. Yeah, always unit A, but then it doesn't care because it just returns this unit. Okay, so B goes into always unit. Oh, I thought it was something else. A to B, okay. So show A. So maybe I was right when I was thinking with the show. Because then, why is that one? I hope it explains this. The problem is it's not clear which show. Oh, so I had it. Maybe I just remembered it because I've read it before. Which show ends A instance we're asking for. Even though there is an A in show A, always A string, we're unable to access it. Always using A is equal to unit for all A's. Yep. So more specifically, the issue is that always unit doesn't have an inverse. There's no inverse type family such that inverse always A equals to A. Okay, yeah, so because we do nothing with the A, we can't know what A is. Thus, we can't give it a show constraint to an A that we don't know what it is. think that's what it's saying. That'd be my best get. In mathematics, the lack of inverse is known as non-injectivity. Cool. Because always unit is a non-injective, we're unable to learn what A is given always unit A. Yeah. Consider an analogous example from cryptography. I think it's the word mathematics. From then it just went right. Anyway, just because you know the hash of someone's password is blah 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 doesn't mean you know what the password is. Okay, that makes sense. Any good hashing function like always unit is one way. Just because we can go forward doesn't mean we can also go back again. Okay, yeah. The solution to non-injectivity is to give GHD some other way to determine the otherwise ambiguous types. Okay. We smashed chapter 4. Might have to do a bit of chapter 5 then. 7. I don't know what time I started. Let's keep going. This can be done like in our examples by adding proxy A parameter, whose only purpose is to drive inference, or it can be accomplished by enabling allow ambiguous type at the definition site and using type application at the call site to fill the ambiguous parameter manually. It'd been nice to get a little example, I guess, just to concrete the understanding, but no. Okay, so, well, I guess we can save that, can't we? And then we can create some stuff. That went quicker than I thought. I'm sure, don't be too cocky, because I've got a very good feeling that it's not going to continue like this. Create file, and we're going to call it Ch5.hs. HD? HS. We're in HD. We're in HD now, and some people can't watch. I'm sorry. What am I doing? Ch01. Chapter. We're on 5, aren't we? Did I call it chapter 5? Yes. Where? Save. It's going to complain. Well, it should complain anyway. I'm going to have to go here. Add it there. Just put random I instead of going in, and then replace those with 5. Close that, and then close this, and then do a bit of that, and then it'll say I'm going to redo stuff because you've changed the cabal of file, which is what it's doing. Oh no, it's just saying it's done it. Oh, okay, thanks. It's happy. Oh, I'm running out of water. It's not water, it's mint tea. Mint tea, what a hipster. Anyway, constraints and GADTs. GADTs. Oh, these are fun. Yeah, I think I came to this book anyway because I wanted to get a better understanding of GADTs. And then I did this, and I also did... what was it? What was it? It's by I Am Tom. Was it Learn Me Haskell? No, Haskell Exercises. Boom! I'm sure this has been passed around a lot. But yeah, I think the first exercise is GADTs. And then what I kind of got through, and I was like, oh, I'm a bit confused. So then I went back and forth a little bit. I'll put that here. Yeah, I went back and forth a little bit between the two. And I think what I'll do... I think Vlad went through this actually in history. So I might do it as well later. Once I've done the book, maybe go that way, because then it'll make more sense. And the other thing is all I think because maybe I'm at a lower understanding than Vlad, I kind of take a little bit longer to try and explain things sometimes, only because I'm just genuinely struggling myself. So it just takes longer for me to explain because I don't get it. So yeah, which is potentially good, because then it means that, you know, we go over things, and then you know, people comment, and then we just try and work it all out together, because Haskell is the world healer and stuff like that. That's what they say, don't they? Okay, let's go back to this. Got carried away again with my nonsense. Here we go. Hold on. I need to make another. Yeah, I need to. First and foremost, I need a little button. There we go. Wow, have some of that. What we need is for people. Can someone who's not following, can they follow? Only because, not because I want followers, just because I want to show my follower animation. Yeah, let me know when that happens. You won't hear the sound though. There is a great sound attached to it, but I've still not worked it out why it's not showing. So yeah, when you get bored, follow, and then you get to see another good animation. Here we go. Has it come? Why did it not come? What? Oh, you're trying to refollow. No, it's caught you out, Gil Christian. It's just gone. Gone. I know what this person's trying to do. You know what? I'm just gonna do it. Do it for the people. Show the animation. Do it for the people. That's not even a song. I'm just making it up. Oh, you should be. I can replay from here, yeah. If I go to follows. Oh my god, I'm very scared because it's going to be really loud in my ear. I'm going to take it off because it's going to hurt. Yeah. Okay. From recent events. Oh, what? So I can just press it. Let's have a look. Report, follow. No, I don't want to report. Yeah, that was it. We can do it again though. Oh, it's going to hurt my ears. I need to... actually, I'll sort out this sound down. I can hear it totally, but it's not coming through. I don't know why. Yeah. Normally in OBS, you just attach a web page and then it captures the sound from it. But in this one, it doesn't. So it just captures the HTML. You get to see the little hands. But that's what you get. You don't get the crowd cheering me on every time I get a new follower. Oh, what a lunatic. Right, let's go back to this. So constraints are odd. They are odd, aren't they? They don't behave like types, nor like promoted data kinds. Professional, well, come on now. Let's be honest with ourselves. I was told that if I want to be able to, well, you actually told me, if I want to be able to allow more than 1080 or go below 1080 so people can click and select what resolution, I need to have 75 watchers, right? We're on 7, so don't know about Pro. Long way to go. Yeah, wow. If I go tenfold, I'm nearly there, and then tenfold and 0.5%, 10.5, and then I'm there. So they don't behave like types, nor like promoted data kinds. They are a fundamentally different thing altogether, and thus worth studying. So we went through kinds, we went through types, how types made up. That was back in chapter 1. But yeah, let's keep going. So the constraint kind is reserved for things that can appear on the left side of the context arrow, or the fat context arrow. I just call it the fat arrow. I think that's because of JavaScript. They called that the fat arrow, didn't they, when ES6 came in? Yeah, those were the days. This includes fully saturated type classes. Here we go. So when you do show on its own, let's have a look. We could do it here, because I've remembered how you do this. There we go. Oh, the star is actually type. I don't know why it's not updated. Is that because of the GHG version I'm in? I don't know. But here it's a star, but it's actually star also is going to be represented with type. So I don't know. So that's that. But then if you see, look, show expects a value. So we know when we look at the definition of show, it's show a equals blah blah blah. Okay. So that's basically what it's saying. It expects a type. So whatever you give show, the type you're going to give it, and then it'll return you a constraint. But when here we fully saturated the type class, i.e. show a, then we return a constraint there. So then once it's fully saturated, it becomes constraint. Okay. So that's how you go with that one. Tuples. of other constraints and type equality. Look at this one. Int is equal to a. Yeah, I've seen that used, but I've never really sort of used it myself. But I've definitely seen it. We will discuss type equalities in a moment. I mean, I think that was a big fib because I've clearly seen it because I've used it right there when I did this chapter before. Can't even remember. Okay, type class constraints are certainly the most familiar. Yeah. We use them all the time, even when we're not writing type level Haskell. Consider the equality function. Okay, so double equals. And that, the type of double equals is eq of a, the constraint eq to a. We give it an a, another a, and we return a bool. Yep. So it's saying, hold on, constraints. Yeah, so this is the constraint right here. So tuples of constraints are similarly well known. Sequence A. Yeah, so applicative F. Traversable. Yeah, so we can have like constraints and we can obviously keep extending that. You'll see it when you like start working on bigger apps. Whoops. A lot of times you have some of that. So T, FA, F, TA. Yep, so it's just saying an F has got to be of applicative constraint and then the T has to be of traversable constraint. Cool. So type equalities are more interesting and are enabled via GADTs or X-GADTs. That's how you pronounce it. Does it say it here? I'm pretty sure that's how you say it. GADTs. Let's get it. Anyway. Oh, I've not got my higher order functions, aka Hoff. Where's my Hoff? We need to bring him out every now and again, I think, Hoff. Because he was quite good. For me. For me. Home. No. Profile. Media. Look at that one. That's the other one. That's the other art. But more importantly, there you go. Hoff is about. I know. Terrible. It did say somewhere in the description there's some terrible dad jokes in these streams. That was one of them. There's another one, look at that. That's meant to be me. Obviously, I've been doing some green stuff. Green. Very purpley face. I don't mind. Oh, but what I like though, which I've not shown, I did show in another stream. I'm going to do it again. You've got to be proud of terrible art. Because why not? Let's have a go. Where was it? This one. Look at this. I can't remember what game that's from. It's the one where you I basically just copied it. Yeah, Journey to Monad Transforms. That one's finished, but we had a journey, and this is us in the Haskell mobile. Going to a... Right, shut up. Back to streaming. Where are we? Go away. I need to have like a button that just tells me to... I need to maybe set up a button where viewers could just like click it if they want me to get on with it. And once I like reach, I don't know, say more than 3 people or 4 people click it, then I know it's time to move on and to shut up. But till then, just have to deal with it. Right, type equalities are more interesting and enable gadgets. Compare the following 2 programs. So we've got 5, which is of the... Let's type them in, let's do it. So 5, which is of... I mean, this is fairly pointless. Yes, is of type int, and that's 5 equals 5. There we go. We killed it. And then we've got 5 underscore, and that's going to be a. It's fairly pointless. So it's a is a constraint. A is equal to int, basically. It's saying, which is fine. You know, that's exactly what we want to do. 5. There we go. Same thing. So both 5 and 5 underscore are identical as far as Haskell is concerned. Yep. While 5 has a type int, 5 underscore has a type a, along with a constraint saying that a is equal to int. So at type level, the squiggly, what is the name for squiggly? Squiggly. That's what it should be called. Is meaning equal. A equals int. Yeah, squiggly. Of course, nobody would actually write 5. I just did, literally. I just wrote 5, so thanks. But it's a neat feature of the type system regardless. Type equalities form an equivalence relation. An equivalence relations, meaning that they are the following property. Ooh, I'm not going to remember these, but let's try it. Reflexivity. A type is always equal to itself. So A is equal to A. Get that, get that. Symmetry. A is equal to B holds if and only B is equal to... Okay, so, I mean, that holds whatever, really, you know, within function values and everything. So this one, what was that? Reflexivity. Reflexivity? So that's like ID. That's just symmetry. And transitivity. Transitivity. I've just missed out the T. Transitivity. If we know both A is equal to B and B is equal to C, we, and more importantly, GHD can infer that A is equal to C. So that's almost like composing, isn't it, in a way? A to B, because it knows that A is equal to B, and then B is equal to C. So clearly, if that's equal to that and that's equal to that, then it can just ignore the B, and A is equal to C. Okay, okay. Now, GADTs. Generalized algebraic data types, or as I call it, hey, there we go, GADTs. Pronounced GADTs are extensions to Haskell's type system that allows... Now, GADTs, you're definitely going to, you know, once... yeah, they do become useful. I think I had it last... Was it 2 years ago, maybe? Yeah, it's 2 years ago. I had it as part of an interview for... Who was it? I think it was IOHK at the time. I think that's who it was. And it was used in... I didn't work for them because it was 2 years ago and I didn't really understand GADTs that well. So I looked at it, tried to do it, and then told... Oh, who was it? Is it Simon Thompson? Simon Thompson? Really nice guy. I had a really good chat with him. And he was all like super keen. But then, unfortunately, because I didn't really know GADTs and I didn't have enough time to do it, yeah, I failed. Which I don't mind, you know. I don't know. Right, let's not comment about things with IOHK and stuff because they do a lot for the community. But I'm not that interested in crypto, so... There we go. I've made that haystack a little bit bigger. Just the way I like it. Right. Are extensions to Haskell's type system that allow explicit type signatures to be written for data constructors. They, like type equality constraints, are also enabled via yes. The canonical example of GADTs is a type safe... Yeah, this is cool. Type safe syntax tree. For example, we can declare a small language with integers, booleans, additions, logical negation. Yep. And if statements. Logical negation. Yeah, not, basically. And an if statement. Cool. Should we type it out? Let's do it. We being me by myself. We being you watch. Hey, where? Oh, you can watch me fumble. That's what you can watch. What is it? Lit int. Okay. And that's an int to an expression. I mean, yeah, if you end up making your own language, you'll see a lot of this. Off topic. Oh, hold on. Here we go. I'm missing like comments, aren't I? Sorry, Helverson. You said squiggly is called tilde. There we go. Or, as I like to call it, squiggly. In maths, it means approximate. What does it mean? There it is. Mathematics. Where's squiggly? There's squiggly. A tilde in front of a single quantity can mean approximately, about. Oh. Or of the same order of magnitude. Just confused why it's used for a type equality. Confused. Okay, well, we can answer that. When we showed this example here, I think it's just in this, because you can have constraints here. It's used as part of the constraint, isn't it? We're just saying we've got a type of A, And you know, when on the left hand side is the constraint area, and we're just saying, well, this a is equal to int, which is essentially, you know, we in this scenario we just don't need the a or the constraint, we could just put int. That's what it means there. It will do. I think from memory it does extend as to other uses of it, but for now I'd think of it like that. You know, it's literally just assigning a with the type int when we're in the left hand side. So if we remember, the left hand side of things is the constraint. So much yeah. Oh, so you confused why the actual tilde is used rather. Yeah, so if you compare what tilde means in maths compared, yeah, I think ideally, you know, it would be some, I don't know, I guess something like, oh sorry, it'd be something like that, wouldn't it? That's basically what's happened. But if you have to have there, then the yeah, that would be interpreted, the lecturer and everything would have a mental day. So I think it was just potentially easier to do that. I don't know, to be in all honesty. We need someone that knows. Someone that knows, please let us know, because it's yeah. I think that's the thing. Sometimes not everything's a 1-for-1, is it? Between maths and Haskell. Yeah, which is usually the same in most scenarios of type languages in any language really. I've not spelled it right. So lit. Yeah, sorry. I hope that helps though. That's as far as I know, other than what I've been reading. So we're doing an expression and we're gonna pass a ball. Okay, let's just do a save quickly. Okay, that's fine. We're gonna add. Ooh, and that's going to be an expression int expression int, and it's going to return us an expression of int. Okay, that's fine. I'll adjust the bit that's not aligned, don't worry, I'm not one of those people. There we go, that was hurting me too. Oh, here we go. So Haskell, as Parsons says, if you give a Haskell a syntax, they'll just want more. Yeah, good call. Well, it's Matt, isn't it? Matt Parsons. I think that's what he's called, yeah. Bool to expression bool. Don't worry, if this doesn't quite make sense, it'll be explained. I'm just typing it out. Look at that, with all the wrong things. I'm searching for there it is. This is the initial encoding, right? Of the type? Yeah. I think that's what you're asking. I'm just going to say yeah. Yeah. Like that. Bool. Expression A. This is an if statement. Expression A. Expression. Look at that. We should have used that one. There you go. That would have sent people going. Hey. Okay, so we got it. So because this ultimately, when you're doing small languages, you've got the ability to recurse in itself. This is like recursion, isn't it? If you think about it. Yeah, because it's calling expression with an int again. But don't worry, it'll be explained. Okay, there's number one. So this is our number one. So and that's our number 3. Okay, the where at number 1 is what turns on GADT syntax. Actually, why is it happy? It shouldn't be happy because I definitely don't think I have GADTs on. So let's find out. Be unhappy or just be happy. I mean, I'm cool with that. I'm cool but confused. Let's get rid of that. What is it? It's just is it like that? I don't know, let's find out. Okay, well, first and foremost, things. Wow, look at that. Do you like that? Hey? Beat that. Whatever I just did. Oh no, I'm going to put it back. No, What are you doing? I won't even put it. Yeah, I'm having it. I was typing something crazy, wasn't I? Let's go there. Let's go there. No. Let's go BBB. X. There we go. What is it? I think it's capital. Yeah. I don't know why. That's what I was trying to find out. With lower, isn't it? Yeah, that's what I thought it was. But look at this. It's like just happy. But it was happy with the incorrect version. Yeah. Okay. I think I'm gonna have to do something different. Let's first and foremost. Let's quit that one. That one. Where are we? Chapter 3. That's fine. That's fine. Yep. And then we'll open chapter 5 again. Okay, so it's fine now. Let's go to the top. And let's say change that. No, you're happy. Okay. Say change that. No, you're happy. Say do something. It's happy. Ah, damn it. Why are you doing this to me? I want you to fail. Okay, let's do this. Now, reload. Still happy. Sweet. It's good, isn't it? Let's do this then. Whoa. Let's quit, yeah? You watch. I'm going to be the winner of you. Quit. Don't know why that opens. Where was I? Where am I? Here we go. Let's reopen it back up then. Sorry about this. At least once a stream. I've got it open. It's fine. Press zoom a load of times. Bring it open here. I might actually, whilst I'm here, what I might do is rm rf dist. Yeah, let's just get rid of it. And then like that, our Haskell language server will just build it, which will be a good call. So we'll go into source, we'll go into chapter 5, we'll call chapter 5, and then it might take a little while. Yeah. What? It's done it straight? No. There we go. It kind of like jumped a little bit, didn't it? Let's see. What is wrong with you? What's wrong with you? Well, it's definitely saved. There's definitely a 5 in there. Have I got it as... No, I don't have it down here. That's a bit odd. Okay then, so let's do... I'm doing a kebab bilf. Oh my goodness. Build. Just do something, please. Warning. That's fine. Can't find source. Chapter. Okay, this is why there's an error. Have I named it the wrong thing? I mean, you know, let's go back to basics. Yes, look. There's our error. Someone. Who typed that? The idiot. And why didn't it warn me about this? Alright, let's make it right. First and foremost, let's do this. Let's go into here. Let's build, and then can't find source. Chapter 5. Have I not changed it? Inside the... Let's go here. Let's go here. It's definitely chapter 5. Okay. Let's yank that. Oh yeah, let's just do that. Go in here, go into there. Paste it. I mean, they look... Yeah, there's another error. Look at that. Oh dear. Oh dear. Might explain why we're having issues. No, I think you'll find we're correct now. Thank you. Let's do that. Let's do this. Save that. Let's go back here. Let's build. And then it's going to be happy. Warning. Warning. We don't mind warnings. Can't find source. Have I named the folder incorrectly? No, and there it is. File name. Good spot. You would have spotted that technically before me, because you're in the past, in the future, in the past. I'm in the future. You're in the past. I can't do things properly. Okay, let's start again. I was like, yeah, I've got this covered. 5. Who needs zeros? Cool. So now we've got errors in chapter 4 and all sorts of trouble. Okay, so there's an error in chapter 4. Well, I can fix that error in no time. By oh, okay. Yeah, so we haven't just add. There we go. It's happy now. Cool, that's fine. And then this should be happy. Let's go to the top. Let's make it do an error. Yeah, there we go. We're back online. Back online. Okay, we got it. Let's go here. Let's go here again. Let's go like this. Back to what we were saying. So yeah, this potentially looks a bit confusing, but hopefully this will explain it a little bit. So the where is what turns on GADT syntax for the rest of the declaration. I guess so. That's a bit sort of no, because when you do data array.where, I guess. Okay, anyway. In this instance, probably. So each of a lit int and lit bool, add, etc. corresponds to a data constructor of expression. So there. Non-mobile constructor. Yeah. Okay. These constructors all take some number of arguments before resulting in an expression. For example, lit int at number 2 takes an integer before returning an expression of integer. On the other hand, the data constructor if at 3 takes 3 arguments, 1 expression bool and 2 expression a's, and returns an expression a. Yep. Yep, which is what it does. If something bool, 1 expression, then another expression, and then return. Yep. Okay. If it is the ability to specify the return type that is of particular interest. So it's the ability to. So if we look, it's the fact that we know, like in add, when we do add, it's just int to int returns us an int, but we're doing the same at a type level. So characteristical. Otherwise, you would use an equal sign. Oh, here normally. Oh, yes, of course you would. Oh, yes, because normally that'd be type. Yeah, okay, you're right. Sorry, my bad. That's what makes a GADT. I end up just, yeah, I don't know why. Sometimes, yeah. Type is an alias. Ah, okay, that makes sense. Yes. Where were we? Blah, 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 blah. For example, takes an int before returning an expression int. So this is there. Yes, that takes an int and returns an expression int. Okay. On the other hand, the data constructor, blah blah blah. So we've got that. Is this ability to specify a return type that is of particular interest. You might be pleased that expression or expr is correct by construction. We are incapable of building a poorly typed expression. While this might not sound immediately remarkable, right now we're just like, meh, whatever, meh. That's what I do because I'm half French. Meh. When I'm at a cafe. I know I don't sound it, but I was born there. Right, we've reflected the typing rules of expressions in a type system of Haskell. Let's have a look. While this might not sound immediately remarkable, meh, it is. We've reflected the typing rules of expression in the type system of Haskell. Yeah, that is pretty cool, but we'll see why. Show us an example. For example, we're unable to build an abstract syntax tree which attempts to add expression int to an expression bool. To convince ourselves, we need some convincing. Can relate to that. I think we definitely need some convincing. No. Okay, and here what we can do is load Ch5. All named correctly now. Well done. So, what's the type of lit int? Lit int is well, it takes an int and returns an expression int. Okay, and lit if. No, it's just if, isn't it? Hello. There we go. So okay, that just shows us exactly what we've got. So that's cool. Because GADTs allow us to specify a data constructor's type, we can use them to constrain a type variable in certain circumstances. Such a thing is not possible otherwise, number one, or equivalently, as we'll see, without type equalities. Okay, so the value of GADTs is that Haskell can use the knowledge of these constraint types. In fact, we can use this to write a type-safe evaluator over expression. You know what? Let's do it. I want to see this type-safe evaluator. Expr. And it's going to be an expr A to A. Let's do it. So eval expr lit int I equals I. Oh, okay, right. Let's do that a few more times. What are we going to do here? Bool. And we'll make that B, eh? So what it says? Yeah, there we go. It does say that. And this is like the clever bit. Okay, add. Except I've got to do X and Y here. X and Y. And then we're going to do eval. So we've got to do the recursion here. I was thinking that it was actually doing the expression, but it's not. We're just declaring what expression is from within the types. But here we need to call this again because we don't know what the X will be, so we need to eval expression the X. The Y. That makes sense. And then I don't know why it's happy. Not. And it's going to be X. Yep. And that's going to be not. And then we need to find out what the X is. X. Okay, that makes sense. And then if. If is a little bit more interesting. If bxy. Bxy. Sweet. You know what? I could just bring this down a little bit. Come on. There we go. So we can do it like this. If eval. Why don't you find it? Come on. Oh, something's broken. Eval expression of B. Then we're going to do eval expression of X. Else eval expression of Y. Let's just reload things just to double check. Did that say something times out? Maybe that's what's happening in the background. Yeah, kind of. Okay. Well, first and foremost, they're not lint, they're lit. So that's a good start. Let's do some of this. There we go. We've aligned it all. Cool. So we've got this now. What are we on? Okay, I'm going to keep going a little bit. Oh, I kind of didn't want to stop halfway. How much have we got to go? I'm going to keep going. Keep going. Oh, no, definitely not going to be able to deal with these. It's not that far. It's not that far. We'll see. We'll see how I get on. If it gets a bit too much, you know, there's that other stream that's going on with Emacs. Don't know what it was. Might be worth a watch. Right, let's go here. Let's go reload this baby. We've got it. So we want to... Oh, you know what I'm going to do? I'm literally... It's going to... Oh, I could type it out. Sometimes. You know, stop being lazy. Lit int 1. And then we're going to add... This is quite cool when we try and break it down. lit int 5, and then it's lit int 13. So let's copy all that. I've not looked at the answer, so we're gonna do a bit of this, we're gonna do a bit of this, and we'll try and work it out. So if the type if, okay, so we're going to pass all this into eval expression. So if that's just false, then return that. So that's return if it's true. Otherwise, so if then, so if that's true, then do that, else do y. So here it's obviously going if false. You could have had anything in there. Then that's another yeah, add 5 and 13. So I'd assume that 18 would be the answer. Yes, there. Okay, let's find out. You best be 18. 18. Bam! And if we look, they're all types, aren't they? That we've just passed to eval expression. And it's also demonstrating how add, we see how it's passed lint 5. It'll keep going. So when we've done with add, it's done lit int there, so that's why we have to eval expression, because at that point we've just done add of, we're still wrapped around the lit int, and we need to take it out from here, and that's what it's doing. And then this is why we then do the if, which is the left hand side, which is the then, and this is the else. But if we were to do exactly the same and do true, then it returns 1, right? Which is what an if else do. But of importance, we're doing this at, you know, ultimately look what I'm passing in. I'm passing in like a bunch of types. Crazy. Okay, but don't worry, it makes a little bit more sense. So pay careful attention here. At 1, so where's 1? Up here. Okay, so let's have a look at where 1. That's 1. No, are they still referring to those? I think they are, yes. So that's 1, and that's 2, is what we're talking about. It's a little bit further down. 1? Pay careful attention here. At 1, eval expression returns an int, but at 2, it returns a bool. Yep. Okay. This is possible because Haskell can reason about GADTs. In the lit int case, the only way such a pattern could have matched is if a is equal to int. Because in which one? Lit int case. If a is equal to int. Let's have a look. In the lit int case, the only way such a pattern could have matched is if a is equal to int. In which case, it's certainly okay to return an int. The reasoning for the other pattern is similar. Haskell can use information from inside the pattern match to drive type inference. Okay. Yeah. So it's saying... Oh, because of here. Okay. Surely. Yes. Okay. That makes sense. Yeah. So GADTs syntax is indeed provided by... Yes. But it is not the syntax that is fundamentally interesting. The extension is poorly named. A more appropriate name might be X-type equalities. In fact, GADTs are merely syntactic sugar over type equalities. We can also declare expression as a traditional Haskell data type as follows. Look at this. That's a bit... I mean, I know which one I prefer. But here, so it's saying... So we have all the constraints which we were using before. So it's just saying that data expression equals... And this is where it differs. And that's what you were saying... Chiroptical. That's it. You were saying that here it should be... Because we're using away, that's what... where instead of an equal. That's what makes it a GADT. And then we can see this is like a sum type. Because of all these little fellas, and we're doing type constraints, so whatever a you pass along, it's saying that a is equal to int, the constraint of A is going to be to int, and then we return lit int that takes an int. Yep. Sorry, so there's a type lit int, lit int, which is equal to int. And so yes, we're dealing with another little phantom type of such, it looks like, except this one doesn't have, if doesn't have a constraint. So why does if, let's have a look at it. Oh, because of the A. Yes, okay, because the A is like from there rather than here. These we want to be, but then there, whatever the expression is, we want it to go back round and check if it's a bool int or blah blah. So when viewed like this, it is a little easier to see what's happening behind the scene. I guess it is a little easier, but at the same time, it's potentially a little bit more confusing. I think I understood what was going on here more than I understand what's going on here, or maybe I don't. I don't know. So when viewed like, each data constructor of expression underscore carries along with it a type equality constraint. Like any constraint inside a data constructor, Haskell will require the constraint to be proven when the data constructor is called. As such, when we pattern match on data constructor, which contains a constraint, this satisfies a constraint comes back into scope. This satisfied constraint comes back into scope. But what are you on about? What's going on here? Wow, I kind of don't want to read it again because there's too many constraints. Okay, let's start. Each data constructor of expression underscore carries along with it a type equality constraint. So it's carrying along that. Yep, so we know we've got that available. Though it's not used on the right, but it's there. Yeah. Like any constraint inside a data constructor, Haskell will require the constraint to be proven when the data constructor is called. Okay, so wherever that's called, it's got to be, this constraint has got to be proven. Okay, as such, when we pattern match on a data constructor which contains a constraint, okay, so when we do a case of whatever, which contains this satisfied constraints comes back into scope. Case of, okay, I get you. That is a function. So that is a function type expression A. Oh, to A, I nearly didn't say that. Can return an int. Expression A to A can return an int when pattern matching on lit int, but returning a bool when pattern matching on lit bool. Okay. The type equality constraining A only comes back into scope after pattern matching on the data constructor that it contains. Okay. Well, we will explore this technique of packing constraints inside data constructor in much greater detail later. Though GADTs syntax doesn't offer anything novel, we will often use it when defining complicated types. This is purely a matter of style, as I find it more readable. Yeah, I think I prefer that for sure. If that's of any use. What are we doing here then? Let's do this one. This is not going to copy and paste nicely, but is GADTs in there already? Yep, it is. So let's go to the Control A, Enter. Yeah, there we go. That's what we wanted. Clearly, I said this isn't going to paste well. That's correct. Where is it? There we go. Let's go some more. 2 more. 1 more. Save. Okay, that'll do. I'm not going to line them. Import. Here we go. So we'll do some of that. Import data.kind and king. Yes, we want some kings coming in. Constraint. And we want type. Yeah, not used. That's fine. That's what we want. Yeah, we're at the bottom of the page now. let's go, let's go, let's go. Right, one of the primary motivations of GADTs is building inductive type level structures, okay, out of term level data. So term level, okay, so we want building inductive type level structures out of term level data. Wow, okay. As a working example for this section, we can use GADTs to define something list. Oh, this is one. So that word, heterogeneous, genius, is basically a list of multiple types. Yeah, I remember looking that up and going, what is that? Yeah, so that's basically a list which can store values of different types. There we go. Could have just defined a, there we go, could have gone delete that and then just gone delete that and gone straight onto there. To get a feel for what we'll be building, so this is just demonstrating. So Hdl is a H list of a tick. We did ticks, didn't we? Yes, that was part of kinds in the other chapter, so we were able to find what that happens with the tick. Yep. So Hdl returns this Hdl of Hlist empty list. Type of true, that and nil. True, that and nil is of the type Hlist list of bool. Let Hlist just hello and true Hnil. And then if we look at the type of that, it's a maybe of char and then comma a bool. Yes, and that's a nil. So it looks like this, you know, when we do this. And then we go onto there. Yeah, that's, I mean, if you look at it, it's literally, except we're doing H-nils and that would be different. Okay, that's fine. And the length. Cool. So the Hdl constructor here is analogous to the regular list constructor there. So, and that likewise corresponds to cons. Yeah, they're defined as GADTs. Let's define them. Let's do it. Data Hlist T. Oh, I remember asking. This is where I asked a question, and let's see if I remember the answer. Okay. It was later, I think I asked. I got stuck and then. So we've got a Hnil. That's of the type Hlist there. So we can do, whoops, there. Okay. And then we're going to define this, which is like that. And that's of the type T to Hlist, TS to Hlist, and then T. Oh, hello, TS. And then we can do here, infix, probably. Okay, well, we can give it like a little gap. Okay, now at 1, you'll notice that we've given Hlist TS an explicit kind signature. The type parameter TS is defined to have the kind list of type. Yep, that makes sense, because we'll store the contain type inside of it. Although this kind signature isn't strictly necessary, GHC will correctly infer it for us. Your future self will appreciate you have written it. A good rule of thumb is to annotate every kind if any of them isn't type. Cool. So because we've got the other, so we're declaring a TS here, and we're saying that it's of the type list of types or list of type, and then yeah, and then we use it like that. Okay, and then if we get a Hnil of the type Hnil, then we know it's a H of list, and it's just an empty list. Yeah, and then if we use like a cons, so we pass in a T, a H list of TS, which is going to be a list of types, and a h list of, and it returns, sorry. So that's what it takes. That's the other value it takes, and then it returns the t const onto the ts, which makes sense. So you know we're adding that t inside of there. Okay. So what did we do? At 1, you'll notice we're given h list yes, because we'll store a constraint type inside of it. Although this kind signature isn't strictly necessary, GHC will correctly infer it for us. Appreciating blah blah blah. Okay, h list is analogous to the familiar list type, and so it needs to define an empty list at 2. Yeah, so this is why it defines that there. Okay. And so it needs to define an empty list at 2 called hdl and a cons operator at 3. So there's our cons operator called :hash. These constructors have carefully chosen types. Hdl represents an empty h list. We can see this by the fact that it's taken nothing and gives back ts, which is equal to empty list. Okay, yeah, an empty list of types. The other date constructor :hash takes 2 parameters, and its first is of type t and the second is of h list of ts. In response, it returns a h list const onto t, h list of t cons onto ts. The result is the new type have been consumed onto other h list. So that's just cons in. Yep, the h list can be pattern matched over, just like we would with a regular list. For example, we can implement length function. I mean, what in earth? What in earth? What on earth is, especially if you spell it like that. And we're going to return an int, and then we're going to have a h. You going to find it? No, it's not. Why are you not? No, of course it is now. H nil. And well, yeah, we know if it's h nil, it's going to be 0, isn't it? And then h, and then we're going to have to do some sort of recursion, I'd assume. Let's have a look. Yes. So, and then here we've got, we don't care about the first value because we don't want to count that. And we've got ts, and then just like, you know, we're just going to, we're just going to recurse until there's nothing left. And then when the list is empty, we'll just return 0. So that makes sense, doesn't it? It's just what you'd normally see in lists. Yeah. Oh, what's the time? Okay, keep going a little bit. But having this explicit list of types to work with allows us to implement much more interesting things. To illustrate, we can write a total head function, something impossible to do with traditional lists. And we can do this by h head, and that's h list of t, and no, this one, no, oh, I wish it wouldn't double up on things. Let me make it so t cons onto ts, and it returns us a t. So basically we're saying we've got a h list of t and ts. We can grab this, yeah, this is part of our type. We can grab that t out and give it, okay? So h head, I'll show you, we'll play with it as well, I think, because it might not be apparent why it's a total. Let's reload, and let's do h head. So we've got to pass it a h list. Okay. Doesn't it even show us? Okay, so we can pass it like. What should we pass it? I've got a feeling this isn't going to work. Let's try it. Yeah, I thought so. Oh, what are you on about? Oh, yes, okay. So it's not going to be like that. So it's going to actually be like this. It's going to be a H. Where was the examples? They're a little bit above, weren't they? There it is. So we want something like this. Yeah, here we go. So we go like that. Yeah, of course. Oh my goodness. Like that. And then we'll do another one. I don't know. What should we do here? Should we do ball? Oh no. False or true? Yes, okay. That'd be fine. Why are you not happy? It's clearly there. I've done it as an infix. Infix 5 is the same as infix. Cannot mix that and infix 5. And that and in. Where have I got it wrong? So look, let's try it again. Let's do it like this. Let's do it like this. Okay. Let's do it like... Is that going to work? No. Why aren't you going to work? Maybe I need to do it at type level. Okay, let's keep going. Let's keep going. The oddities don't stop there. We can deconstruct. Yeah, it'd been nice to get an example. Would have been nice. I guess I've just lost. Why we haven't got that. Oh, right. Okay, what's the time? I don't think... it was this one I got stuck on, but I worked it out. Or was it this one? I think it was odd. I might stop here just before the exercises, to be honest, because I'm looking at the time and I think I've done more than I planned. But I'm a bit sad that we don't get shown how these work. Either I'm being... Okay, well... Okay, so we've got... Here we go. So this is clearly a H list. Okay, well let's just copy this first. I want to make sure this works. Okay, so we've got... No, so it's not passing. I guess I need to bring in... Oh, you know what? We'll just do it here. Okay, here we go. So we've got it in there. And then we can reload it here. I'm assuming... What do you mean? Cannot mix in the same expression. Can someone please tell me, or can someone tell Haskell to behave? Do 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 do. Oh, we like jumped with an error. Oh, here we go. Now we've got an error. Why not then? A passing error. Have I mean, I've clearly... No. Okay, is it because of this? Yes, I think it's because of that. It is because of that. Tut, tut, tut. That could throw us. Which is exactly what it did. I'm assuming. Let's reload and find out. No, it wasn't that at all. Fuck. I thought it was that. Well, I might just stop there. Take defeat. We were going well, and then, I don't know, just started coming down, didn't it? Infix. Infix. That's my fault. There. Okay, it's got nothing to do with anything. It's purely me. There it is. And there's missing a nil at the end. Okay, let's do length. Miss out one letter, hey? One letter. At least we get to see it working though, so that's what counts. H list? Just hello. So that definitely grabs it. But let's find out H head of what happens if we give it an empty list, which would be H nil. Yeah, so it's just not even going to type check, which makes sense. Couldn't match type with T. Yeah. Okay, that makes sense. Let's go back. Head. Okay, so the oddities don't stop there. We can deconstruct any length of free hlist whose second element is bool. Show it and have the compiler guarantee that it's an acceptable, if strange, thing to do. Yeah, I've seen it. This one's quite amusing. Let's do that here. There. Go show bool. I can explain this one. There. Let's go make some gaps. Let's go like that. It's going to be show B. Show B. Okay. So if we look at the type, we've got a hlist, which we deconstruct the list in the type, and we're saying ignore the first, ignore the second. I mean, but if the ignore the first and the third. If the second is a bool, right here, B, then grab it and show it. Which just seems like utter madness, but it works. We can do that by changing this here to be that's a bool, and we can have another value which would be yeah, we'll just do just another. Whoops. Yeah. Whoops, I forgot to do that. Cool. So we've got a list now that's got 3 values. 1, 2, 3. The second one is bool. So if we use show bool on this list, it should work on h list. True, that works. But if we to convert this to just whoops, boop, like that, and then we refresh, and then we show bool, and we pass h list, then we get a type error. So you're going to get this type error, obviously not at runtime. Pretty clever. You definitely want to do it, but it's pretty clever. Unfortunately, GHG stock deriving machinery doesn't play nicely with GADTs. It will refuse to write EQ and show or other instances, but we can write our own by providing a base case for hnil and an inductive case. The base case is that 2 empty hlists are always equal. Yeah, I'll stop there because you end up making the others, and then it shows you a better way to do it. But yeah, I think that's a good place to stop. I'm getting hungry, and I've probably done more than I thought I would. So the 1 chapter per stream is going well. We've done like 1 chapter and a half, I think, for this one. So that's pretty cool. Yeah, and I guess I'll do. Oh, shall we see? Oh look, what's going on? Got a new subscriber. Thanks. So what we should do is look if anyone else is streaming and see if I always forget to do this. I don't. Who is there? Hold on. How can I know? Does anyone know if anyone else is streaming? We can raid them. Obviously, they have to be within Haskell because I'm not interested otherwise. Watch me code. There doesn't seem to be anyone else streaming right now. Let's find out. We'll go to there. We'll go to here. Don't play with me again. Quick, get out. Oh, that was horrible. Obviously I can hear my voice in my head, but when you hear it playing back, it's not so nice. Where are we? We want to go to this one. It's going to hear me again. I'm muted, so that's fine. Raid. Who can we raid? Pick a raid. There's no one. I wish I could just channels you follow. No. Okay, well, we're not going to raid. Sorry if anyone's raiding. But, yeah, let's get rid of that. That'll do. Cool. Okay, well, I'm going to stop there. I think we did well. Oh, no, let's plug this. I'll put that up on here as well once it's finished. There, we'll add it with our amazing little pictures of thinking with types. And then we'll shut that. Unfortunately, no one else is streaming. You can carry on. But, yeah, well, thank you very much for coming and listening to my rant. And I think I normally do, but I think I'm sort of aiming around the same time. 4 seems not too bad. 4 p.m. Eastern